we're back again. You couldn't keep us away. We're in our laboratory, and today we're going to bring some Frankenstein potatoes to life. With what? Electricity! And to tell you more about electricity, here is mad scientist Caroline.
So electricity is a type of energy that can build up in one place or flow from one place to another. So we use it every day. You use it to make toast. You use it to turn on lights and even power up the device you're watching this on right now. So the history of energy dates all the way back to the ancient people when they used fire to heat up food and protect themselves. Eventually, people started inventing tools to increase natural energy. So they invented the wheel to harness energy from animals to harvest their crops and even grow food. And then that went on to water wheels and windmills. So that helped produce energy to complete things like watering fields and even grinding grain into flour. The discovery of energy has been around for a long time, but the discovery of electricity is a little bit more recent. Forms of electricity have been known about for a while. So electricity got its name from the Greek word electron, which means amber. That's fossilized resin from extinct plants. The early Greeks found that when they rubbed cloth over amber, it created static and attracted dried material, so static electricity. So Benjamin Franklin's famous kite experiment with a key attached to it wasn't discovering electricity, but it proved that lightning was a form of electricity. There are a bunch of different scientists and inventors you can learn about that contributed to the discovery of electricity. And science of magnetism, such as Michael Faraday, Thomas Edison, Nikola Tesla, but we're not going to talk about those guys today. Today we're going to talk about current electricity. So I've already mentioned static electricity. Now we have current electricity. When electricity gathers in one place, that's the static electricity. That means it doesn't move from one place to another. Electricity that moves from one place to another is called current because it creates a current. Today we're going to experiment with current electricity with circuits and potatoes. Now I'm going to send you back to scientist Kathy.
Hello, I'm back again. All right, guys, so I'm going to explain our experiment to you. In most commercial batteries, electricity is generated by a chemical reaction between the two electrodes. That would be copper and zinc. Now, in our experiment, I have actually pieces of copper and zinc, but at home, you can use copper pennies and zinc nails, okay? But you do need copper and zinc. We need an electrolyte too. So the liquid in the potato acts as an electrolyte and will generate electricity between the two electrodes. A potato battery is a type of battery that's known as an electrochemical cell. The chemical zinc and copper in the screw in the penny, or as here, my zinc and copper plates, they react with each other, which produces chemical energy, okay? Then the chemical energy is converted into electronic energy by spontaneous electron transfer, all right? That's a lot of big words. The potato acts as a buffer and an electrolyte for the two metals, all right? This means it separates the zinc from the copper, forcing the electrons to try to get from one metal to the other. So we're causing a lot of disturbance here. So what happens is once we connect all these, it travels through the potato because of the electrolyte solution there in the potato, and it forms a circuit, okay? The two metals would still react if they touched each other, but without the potato, but without the barrier and the electrolyte, the energy released wouldn't form a circuit. So in other words, you can put a zinc nail and a copper penny together all day, but if there's nothing there to form a circuit with them, it's not going to do anything, all right? So we are going to do, and let me show you what I've done here. what we did is I put in, let's say, these copper plates right here. Those would be your pennies. These zinc plates right here, those would be your nails. So it's very simple. And then you take, let me take one of these off. Don't wake the potatoes. Then we have a circuit. That's what this wire is, okay? So what we're doing is we're attaching these gator clips to the circuit. You can just do this. You don't have to have the gator clips and all this fancy stuff. You could just get a piece of wire and strip off the insulation at the end and put it on, wrap it around the penny and the nail. If you do that though, when you connect the final one, be careful because you might get a little bit of a shock because of the electricity that's going through. Alrighty then, are we ready to bring to life our little poor sleepy, or maybe dead, potatoes? Okay guys, here we go. I need everybody to count. 1, 2, 3. And, oh, look everybody. If you could curl that over a little bit and we could get a good shot of that. Do you see that light bulb has come on? Look at that. That is because we are forming a current with the copper and zinc electrodes and the electrolytes in the potatoes. And look, we brought our potatoes to life. All right, folks, we would like to say thank you for joining us with our wonderful experiment. Scientist Caroline and I have now more experiments to do. Scientist Caroline, what's our experiment for next month?
I think we're experimenting with turkeys.
Turkeys? In November?